What is waste gasification? Firstly, gasification is the process of heating a feedstock material to a temperature that breaks it down into a gas of its constituent materials. It does so without combustion and thereby avoids the production of greenhouse gases. This heated gas of various molecules is called synthesis gas, or syngas for short. Syngas can be used to synthesize many useful everyday products needed for industry, transportation, or energy. In the case of waste gasification, it is used to remove waste materials while producing useful products, a two-in-one solution. So, how does waste gasification work? Trucks carrying the waste or feedstock material would bring it into the gasification plant. The feedstock material is first shredded and then deposited onto a conveyor belt that brings the material to a storage silo. From the silo, the material would enter gasifiers. As feedstock enters the gasifier from the top, it first undergoes the process of torrefaction, which removes volatile compounds. This usually occurs at temperatures of 200 to 300 degrees Celsius. As the feedstock moves further through the gasifier via gravity, it enters the next temperature zone of 400 to 800 degrees Celsius. Here, depolymerization and pyrolysis of the hardier materials occur. From here, the materials enter the carbonization and gasification zone, where temperatures of around 1000 degrees Celsius are achieved. Most materials are broken down to their simplest forms, namely carbon and hydrogen, with trace amounts of other elements like sulfur. Finally, there is an injection of limited amounts of oxygen and steam that leads to a heat-producing or exothermic reaction. This maintains the temperature at around 1100 degrees Celsius, but crucially does not allow combustion due to the limited oxygen environment. This prevents the system from directly generating greenhouse gas emissions. In this step, the water of the steam is broken down into hydrogen gas and oxygen. The oxygen combines with the carbon found in the feedstock to form carbon monoxide, and the hydrogen remains as a gas. In this phase, the trace elements like sulfur also combines with some of the hydrogen and oxygen to form side products like sulfuric acid, which can be sold as a valuable commodity. The remaining gas mix of carbon monoxide and hydrogen is called syngas. Any remaining solids like metal, glass, and stony materials can exit the system into a storage container for advanced recycling. The syngas can be used directly for electricity generation or can be processed further to create renewable fuels, hydrogen or ammonia for energy or fertilizer production. The advantages of such a system are great. There is no combustion and therefore no direct release of greenhouse gases. It is a self-sustaining system, as the system utilizes some of the produced syngas to keep operating independently. Syngas and its products are of a high purity and can match the environmental standards of even the most stringent countries. There is a near 100% reduction of waste volumes. The system does not require much land area to handle large volume waste. The system is modular and can therefore scale according to the needs of an area. It can also adapt to change in feedstock profile and quantities. This enhances resource recovery, as non-gasified material is clean of pathogens and can be readily separated for greater recycling and reuse. Overall, it has a superior environmental and social impact. Compared to other waste management methods like incineration, this system offers improved environmental and social benefits, promoting cleaner air and healthier communities.